Good day, Kolehiyo ng Kantukan. Today is August 10, 2023. I am Rondin Grace Giao and you are watching Modern Geometry News. The headlines: Hyperbolic geometry is non-Euclidean geometry. Discover. Find out the hyperbolic geometry models and the hyperbolic real-life examples. Learn the parallel lines and triangles in hyperbolic geometry. What would be the physical effect of hyperbolic geometry in real life? Hyperbolic geometry is non-Euclidean geometry. We have Sunshine Ganap on the screen.
Thank you, Ms. Giao. Hyperbolic geometry is a non-Euclidean geometry. Hyperbolic geometry is a geometry for which it accepts the first four postulates and negates the fifth postulate of Euclidean geometry. So, it is called non-Euclidean geometry. Here is the regular flat 2D Euclidean plane. It goes on every direction and has no curvature. Here is a hyperbolic space. It could have plenty of squares in a vertex. This is a hyperbolic crochet. It is hard to visualize anything because flattening it could start curving everywhere else. It's impossible to see it all at once. It does give you a sense of how much larger the hyperbolic space compared to Euclidean. Back to you, Ms. Giao.
Thank you, Ms. Sunshine. Find out the hyperbolic geometry models and the hyperbolic real-life examples. Rexport Team on the screen.
There are four models commonly used for hyperbolic geometry. These are the Klein model, the Poincare-Dish model, the Poincare half-plane model, and the Lorentz of hyperboloid model. Hyperbolic shapes can be seen everywhere. Its examples are corals, crochet, cosmos, lettuce, flowers such as cactus and calla lilies. Even the ruffles on your clothes are considered as hyperbolic structure. Rexford Team Jr., Modern Geometry News.
Learn the parallel lines and triangles in hyperbolic geometry. Miss Rosalinda Aman on the line.
Learn the parallel lines and triangles in hyperbolic geometry. Talking about the parallel lines in hyperbolic geometry, remember that hyperbolic is opposite of spherical. So if the parallel lines of spherical geometry converge, then hyperbolic geometry do diverge and Euclidean stays parallel. The sum of angles in a triangle in Euclidean space is 180 degrees, and spherical is always larger, which is greater than 180 degrees, and in hyperbolic geometry is less than 180 degrees. Rosalinda Aman, Modern Geometry News.
Thank you, Miss Rose. What would be the physical effects of hyperbolic geometry in real life? Let's find out with Jerbre Reyes.
What would be the physical effects of hyperbolic geometry? In real world, objects are made up of smaller particles, and when an object moves, all its particles move as well. But remember that there is no parallel line in curved space, so an object's particles all move in same direction. In spherical geometry, it is like squishing the tidal force and trying to move. And in hyperbolic space, object experiences stretching tidal force as they move. Enough space and curvature, hitting physically a hyperbolic baseball that would be ripping apart. Jerbe Tolosa Reyes, reporting.
Thank you for coming with us in this journey. This is Modern Geometry News. And stay hyperbolic.